I work at kinzin.com. I'm in charge of the development team there. We do photo sharing for private groups, and from there, print products. We use a lot of JavaScript, but that's not what I'm here to talk about. And this is one of only 2 slides I have, so we'll get back to the second one at the end. What I would like to talk about is pervasive computer literacy. So how many people here have not heard of Alan Kay, or don't know who he is? Right. So Alan Kay, he worked on the Alto, which became the inspiration for the Macintosh. He worked on Smalltalk, which beget Self, which beget JavaScript. And one of his more famous quotes, perhaps, was that the computer revolution hasn't happened yet. I think during the dot-com bubble, people got too busy making money to actually make computers better. And we're just getting back to where they left off. So one of his inventions that never actually saw the light of day, it was never a physical invention, it was more of a conceptual one, was the Dynabook, which was a computer small enough to carry around that a child could program. And so we're halfway there. We've got the computer that you can carry around easily. Now, how many people have seen the blog posts and people complaining that kids these days, you know, when I was a kid, BASIC was on every computer, and we learned with peeks and pokes, and we liked it. Now, they tend to ignore the fact that there is programming tools freely available for every computer. It's only a download away at most. But more importantly, every web browser is a programming environment. It's just not as easy to bootstrap into it, to sit and write your JavaScript and have people able to see it and test it. So I wouldn't want to give everyone BASIC today. I would rather give them HyperCard or Logo or something that gives them a visual feedback, because kids' standards today are more than seeing Hello World on the screen. They want to see moving pictures. So I think we need to promote JS++ and look for a JavaScript revolution in teaching. And I think tools like the ACE editor that we saw earlier, tools like JS Fiddle that let you test JavaScript very easily, Eloquent.js, which is a book that includes a console for testing. I think all of these are useful and important steps. But ultimately, programming is hard, and expecting people to program their own systems is achievable, but it's not going to be easy. And the important thing is to remember what are the irrelevant details that we can take out of their way. So I want to talk to you about something that isn't JavaScript for a moment, which is called Scratch. Scratch is a project from MIT's lifelong kindergarten program. And it lets you drag and drop and snap blocks together to write your program, like snapping Legos together. I have 2 children, and both of them learned to program with Scratch after trying other visual programming languages. There are several. Star Logo. There's Alice 3D. So Scratch is easy enough. I set myself a challenge to make a game in an hour. And for that, I had to think of what kind of game you could write in an hour. And I came up with Solo Pong. So it's Pong in a circle, 1 player, and you can see it's not perfect. So very, very simple. It also, Scratch, it's implemented in Squeak Smalltalk. It has a Java runtime, so you can upload applets for your game. And there's a whole social network that's involved with it. So I put my little game up there, and people commented and gave their high scores and suggestions for improvement and how to fix the little thing with the ball getting stuck. So unfortunately, I can't run Scratch on my my iPad, they're rewriting Scratch now. And they're rewriting it in Flash, which doesn't help me any. So what Scratch gives you is readable code. So not only can you snap together building blocks, but my son, who learned to program Scratch when he was 6, could download other people's programs by the time he was 8 that he didn't understand how they'd done, and read their code and make modifications and then upload his changes. So I don't know if you've ever tried to maintain the code of someone you've never met, but being able to read someone else's code is huge. The other thing it gives you is, we've solved 2 of the major problems with programming. So most languages include array bounds checking to avoid overflow errors. Most programming languages that come out now have garbage collection to avoid memory leaks. Well, in Scratch, you cannot get a syntax error because you can't assemble a program so that the syntax is wrong. It also has built-in graphics editor, and it's easy to create animations in games. It supports sprites, supports turtle graphics, but it has very strong limits. You can't talk to the network, you can't have anything persistent, and it's made for children. So my son already bumped into the limits of this and went on to a program called Game Salad, which lets you create apps for the iPhone, iPad, and also in the past month he started programming in JavaScript with Raphael. So now I want to talk to you about what Waterbear actually is. So Waterbear takes the idea of blocks and brings them to the web. So you can create a program with the same kind of snapping and dragging. As in Scratch, but you can do it in any web browser. Right now, it's mainly tested in Safari and in, Safari Mobile, but it will work anywhere. I'm not trying to build Scratch with this. I'm trying to build a reusable toolkit for building any language with a visual component. So you can use this to wrap Python or Ruby or JavaScript and get the results. So one thing that you can't do with Scratch is see how it's implemented underneath. And here, once you have your blocks, you can actually see what code it's going to generate for those. This has a huge benefit for teaching programming. It's very easy to teach kids how to drag blocks together and snap them. Has, again, like I mentioned, huge benefit for readability, for maintaining existing programs and learning from programs as a form of literature, to learn by reading. And it's got a bridge to text-based code. The other thing is that you can actually write code now on your tablet. So if you've ever wanted to just drag and drop code and test things out with a computer that fits in a bag easily, besides one with a keyboard, you have an option. Now, one of my goals with Waterbear is to keep it really, really minimal and to work with the web, not against it. And I was tempted several times to try and make it more and more like Scratch, and backed off when I thought of easier ways to do it that worked with the web. The workspace, which has evolved with the language, because for a visual language you have to have an IDE, that's 650 lines of code approximately, including the HTML, CSS, and JavaScript. The implementation of the blocks themselves, including the drag and drop, which getting that working across the devices was one of the harder problems. That's about 800 lines of code, HTML, CSS, and JavaScript. And then the definition of the language that I have here, which is based on Raphael library, that's another 650 lines. So there are limits to this system because it's strongly typed, and the typing is built into the blocks themselves, so you can't drop the wrong type into a block. So this block takes two numbers and adds them together and returns the value. So you can drop another number block in there, but you can't drop a Boolean block in. It won't let you. So there are limits in the types of programs you can express with that because we use loosely typed languages. So round-tripping JavaScript code isn't available in this yet, although I do have some ideas for that. Another limit is that as scripts grow, they become kind of unwieldy in size, just in the physical real estate of the screen to see what's going on. So one of the approaches for that is that I'm going to add blocks that encapsulate other blocks. So you make, just like defining a function, you'd be able to define a new block within the scope of the system. And the other limitation right now is that each block has a fixed number of arguments. So if you Waterbear right now is available on GitHub, and it has a website, waterbearlang.com. It's not actually a language, it's a tool for making languages, but Waterbear blocks for making languages was too long to register as a URL. So the website right now just drops you straight into this IDE for dragging and building applications. I'm going to be adding more information about how to define a language, how to wrap it, and how to extend what's there already. And I thought I'd show you how an actual block is made. So this is the definition of all the blocks in Waterbear right now. And the majority of them are just a label and a script. And each of these are templates. So when it sees this number that has a default value and a type, it's going to put an input that only accepts that value. And then the script is also a template. It says whatever blocks follow this will be here, and the value from this input will go here. And then it just writes that out. So it's very easy to wrap libraries and to make new blocks. So does anyone here know what a Waterbear is? Yeah, a couple. So Waterbear, it's also called a tardigrade or tardigrade. It's a microscopic creature. They are the hardiest creatures on Earth known. They can survive vacuum, high levels of radiation, heat, extremes of heat and cold. They're extremely robust, which is where I got the name for this, is that I want this to be a robust system that can survive different languages. So the future of Waterbear includes automatic code layout so that you can import existing code and have it shown as blocks. I want you to be able to create new blocks within the IDE. Being able to do things, again, that you can't do in the inspiration for this in Scratch. You cannot persist things. So persistence right now is user-generated. It will save your script as you run, and it'll save so it has basic persistence using the local storage, but being able to save your own data for your programs for high scores and things. And there are many types of objects that still need to be added. Variables, arrays, objects themselves, actors, and sprites. Ultimately, I'd like to see this become part of a form of active content, where books can be written about programming, and they can include bits of Waterbear as a workspace to work through the problems. And being able to have embeddable scripts that people can reuse. There's a book called Mindstorms by Seymour Papert, in which he describes how children learn. And they learn best by being immersed in an environment. And the only thing that we actually teach that way is language, because we are all immersed in language all the time. What he envisioned, and why he created the Logo programming language, was being able to create worlds that immerse children in different topics. So you could learn physics by being immersed in a physics world where you can play with the laws of physics and see what happens. Being immersed in a mathematics world where you can see why the rules of math are what they are and what would happen if they were changed. Being able to create these worlds and expose them both to children to children of all ages could be a huge benefit to learning and to pervasive computer literacy. If you've seen the Khan Academy, he's doing this for some subjects. The Khan Academy has videos on all sorts of different subjects, and now you can participate in quizzes within the website there. So you can learn, it's self-learning, self-directed learning. I just noticed this morning that John Ressig left Mozilla to join the Khan Academy, which was interesting. And beyond teaching, I'm hoping that this can be a small part of making the world safe for casual programmers. So I mentioned my son, and he's very, very involved in computers. He really enjoys programming. He thinks of himself as a programmer. He's 10 years old. My 14-year-old daughter, on the other hand, is an artist. She's working on a novel. She draws. She plays guitar. She learned Scratch, but she's not interested particularly in programming. On the other hand, when she wants to embed a animation or a quiz or something on her blog, she turns to Scratch, codes it up, puts it up there, and is done with it for another 6 months. So that kind of casual programming and making that accessible to people, I think, is a huge step forward. And I'm hoping that Waterbear can be a small part of that journey. Now, I've gone through my prepared speech. Now, if there are any questions, or I can show how the anatomy of the blocks fit together. Yes?
Does it work the other way around? Can you write the code and then have it build the blocks?
It will. Yeah. That's a hard problem with JavaScript. It makes me appreciate the simplicity of Lisp sometimes, but as far as the structure. Yes?
Is there any thought about how you might use this metaphor of Legos that Scratch uses? Is obviously connects very well. I've got an 8-year-old and a 6-year-old myself. But what about for teaching older, adults? Does this metaphor still work, or do you think there are other metaphors that might work better?
I think that, we need a mix of metaphors and tools. I don't think that this is one solution for everything. I think it's approachable for adults. There are other metaphors that work in other contexts. A lot of image processing and sound processing tools also have visual components like Pure Data or Quartz Composer. where you drag lines to connect inputs to outputs. Those are also valuable, and they show the flow of data through a system better than the blocks. On the other hand, I think the snapping of blocks together is one that people just get very intuitively. So, I think we need more than one metaphor for sure. And also, I think we need to provide bridges between them, which is why I added the text view showing you what the code that gets generated is. One of my earliest experiments with this was to create a turtle graphic system where you could drag the turtle around and it would write the code out for you, and then you could edit the code to see what it would do. So you could learn by doing directly, by direct manipulation. But I think bridging the textual code representation gives them a strong learning path. Are there any other questions? On the website, you can also get to things like the anatomy of the block that show how they are generated, what goes into each of those blocks, which is helpful if you want to extend it. Show you one larger example. So this was, I don't yet have, this isn't the one where the ball moves. So this was a port of my Scratch project. I don't yet have collision detection implemented, so it doesn't actually play yet. But it's just an example of a larger group of blocks showing different event captures. So we have when the program starts, create the arc, position it, and then when the left and right keys are pressed to just move it. So it's pretty simple stuff. The other people who could find this useful are people who really aren't attracted to programming for the sake of programming, but like processing is designed as programming for artists, but it uses Java syntax, which seems to me to be a little contradictory. So wrapping processing JS with this could be a next step. So now I'll get to slide 2, if there aren't any more questions. So thanks to Chris and Laura for the opportunity. Thanks to Brian LaRue for promoting this. The Scratch team for building a system worth imitating. And Seymour Papert and Alan Kay for vision. And Bert Belder saw this on the JSConf website and is already building a language using it. So for bravery and foolhardiness, my first early adopter there. And if you're interested in finding out more about Waterbear, Waterbear Lang on Twitter. It's where I'll announce changes and updates. Thank you.
Country roads take me home to the place I belong. Portland, Oregon, the JSConf. Country roads take me home.